This is the Malm Gulch area, about 10 miles southwest of Challis in the east central mountains of Idaho. This is part two of a two-part series on Malm Gulch. In part one, I focused on some of the rocks down near the trailhead. There's some folded Silurian rocks, and then a beautiful angular unconformity, and then these huge kind of gravel and cobble conglomerates sitting above them. That's the base of the Challis volcanics. I also spent some time in the part one of the video talking about the regional deposition of the Challis volcanics. So definitely watch that if you want a better overview of how complicated and varied the Challis volcanics are. But these are Eocene rocks from about 45 to 51 million years ago. We can see here they've got some layering in them, and they mostly consist of, in this area where I'm at here, it's a lot of tuff. So tuff is actually a rock composed primarily of ash. So the explosive particles that get blown out of explosive volcanoes and then fall to the ground. A lot of this is ashfall tuff. There are some down in the gully back a little ways. Were some larger particles in there, and what I would interpret as lahar deposits. So these mud flows, these slurries coming off the flanks of volcanoes that mix mud and boulders and debris, including any plant remains or logs that are around, can get entrained in that as well. This is kind of a nice little stop here. There's actually a piece of charcoal in the ash right here. So this is a piece of wood that's been possibly burned a little bit, maybe during the eruption, maybe there was a wildfire, something like that. And then the other thing I saw just as I was getting started here is a really beautiful fault surface. So if you look in here, there's this white material which could be either quartz or calcite, but then you can see the sort of fibrous nature of this. You can see the lines going this way. And what those are called slicken sides or slicken lines. So this surface is a fault, probably a small fault in the Challis volcanics. And these lines indicate which way the fault moved during one of the last little movements on this thing. So you can see the direction of movement. Kind of neat. But the main thing we want to look at here is just over here. So when this Challis volcanic episode occurred in the Eocene, the climate in Idaho is very different. So rather than this dry, sagebrush, although we have some nice flowers going on here, landscape we see today, this part of Idaho was much wetter, much more temperate, and it supported a very lush ecosystem, including large sequoia trees. Now, sequoias are a genus of tree that include the famous redwoods of California. So they're absolutely enormous trees. They're among the oldest living trees on the planet. I think some have lived to be about 2,000 to 3,000 years old. And they're also some of the largest trees on the planet, in excess of 300 feet tall in places. And what we have here in Malm Gulch in the Challis volcanics are stumps of these sequoia trees. So this is petrified wood. This is fossilized wood. These are oriented vertically, which indicates that these were the bases of the tree, or probably near the bottom, but they're still in situ. I'll show you some bigger ones around the way, but these ones are nice. And we can see some of the fantastic textural features in this fossilized wood. And the way that fossilized wood or petrified wood forms is we get, obviously we have a tree or possibly a log. So the tree could be living or dead, doesn't really matter. But then one common way that we get these, especially here in the Challis volcanics, is we had these big explosive eruptions, ash burying the tree, or possibly the tree being surrounded by lahars and basically the tree being killed. But then what we get is the tree's completely buried, so it's isolated from the elements. It's isolated from oxygen for the most part, which might cause it to decay at the surface. And what happens is the silica in the ash starts moving. The groundwater picks up the silica in the ash, moves it downward into the wood, and replaces the organic material in the wood with mineral material, in this case silica or quartz. And in a what we think is a slow, but we're not sure, process, cell by cell, it replaces it with mineral material and becomes fossilized wood or what a lot of people call petrified wood. You can actually see the contact here between the woody material and over here. Hopefully you can see some of the clasts in here. So this one might be a lahar deposit because it's got larger particles. It doesn't look as much like an ash, although it could be maybe a tough breccia or something like that. But anyway, we have the volcanic material here, the edge of the tree, then the interior of the tree, and the woody material. Another one right here. And then obviously these don't stick up too high. Some of the larger ones, the BLM, who is the land manager here, has enclosed in fencing. So you can see there's one at the top of the hill up here. There's this one here, and then just beyond it, there's another one. I think I saw one back behind me there, but we can walk over to this one here and look at this really impressive stump from a sequoia from 50 or so million years ago. And this thing's, wow, this thing's huge. I would guess that that thing is maybe 8 or 9 feet in diameter. And if you measured the circumference around it, it's probably closer to 20 or 25 feet. So really quite large. And so these fences have been in place to protect them. If you do come here and visit, please try to just enjoy the sights, but not collect any of the wood. Obviously, if everyone's coming up here and picking up wood or chipping away at these stumps with a hammer, there won't be much left after a few years. So fabulous geology here. The Eocene, we can look over the fence here and get a better bird's eye view of how big this stump is. Yeah, that's more than my arm span across. That's probably at least 8 feet in diameter. Again, one just over this ridge here with some fencing. There's another one right there sticking up. And I believe, and this is all in my book. I have a book, Geology Underfoot in Southern Idaho, and I have a little chapter on Malm Gulch. And if I remember right, some geologists have looked at this hillside and found, because these sequoias sit at different elevations and they're in different beds of tuff or volcanic material. And so what that suggests is that they represent different phases of forest growth. So you had some sequoias living here, an eruption killing those trees, but preserving the roots of some of them or the trunks of some of them. And then they get covered, and then there's another eruption. I think there's like 6 or 7, something like that, successive forests in here. So it shows us that the forest had time to recover and regrow between these explosive and eruptive phases. So part of the beautiful scenery here in Malm Gulch, really just a cool little canyon, a nice little hike, some really interesting geology, and all part of the Challis volcanics from about 50 million years ago.